Yes, friend. In last video, I gave the qualitative concept of standing waves. And standing wave, I told you, is formed by superposition of two progressive waves traveling in opposite direction, which have same amplitude and same frequency. So now I will derive the equation of standing wave uh, in different medium, bound medium. Let a simple harmonic progressive wave traveling in a bound medium in positive x direction is given by y1 is equal to a sine 2 pi t upon t minus x upon lambda. Y1 actually I have taken because I have to write many equations. Now this wave I told bound medium. If the boundaries are rigid, then the wave after reflection from boundary in positive x direction will be traveling in negative x direction. Since after reflection from rigid boundary after reflection from rigid boundary there occurs a change of phase of pi radian. So the equation of reflected wave is given by y2 is equal to a sine 2 pi t upon t plus x upon lambda plus pi. And here we have assumed that there occur no loss of energy and hence amplitude remain as such. Here assuming perfect reflection. Means whatsoever the energy carried by wave, the same return back. Or we can write this as y2 equal to a sine minus here, sorry, minus a sine 2 pi t upon t plus x upon lambda. Here we know sine 180 plus theta minus sine theta. So this is equation 2. If the boundary, if the boundaries were free, या are free के लिए वन are free, then equation of reflected wave y3 there occur no change to a sine 2 pi t upon t plus x upon lambda. The plus sign here indicates that wave is traveling in negative x direction. Now taking the rigid boundaries, we will find the equation of standing wave. So if we are taking these boundaries, taking rigid boundaries, rigid boundaries, the resultant wave will be the superposition of waves y1, wave given by equation 1 and 2. So resultant displacement y equal to y1 plus y2, y1 plus y2 equal to a sine 2 pi t upon t minus x upon lambda, or minus a sine 2 pi t upon t plus x upon lambda. We know here sine C plus sine D is equal to twice sine C plus D by 2 cos C minus D by 2. This is the mathematical formula of trigonometry. I have told many times. Similarly, sine C minus sine D is equal to 2 cos C C plus D by 2 sine C minus D by 2. Similarly, cos C plus cos D equal to 2 cos C plus D by 2 cos C minus D by 2. Learn these equations. Cos C minus cos D equal to minus 2 sine C plus D by 2 and sine C minus D by 2. So here formula will be sine C minus sine D. So how to write the equation there now? तो 2a कॉमन होगा 2a cos c plus d by 2. This is c plus d. When we add, we get x cancelled and 2 pi t upon t plus 2 pi t upon t divided by 2. So we will get 2 pi t upon t. C minus d sine this minus this. Now the term containing time get cancelled and we will get 2 pi minus x upon lambda. As you know, remember this also, sine minus theta is equal to minus sine theta. Cos minus theta is equal to cos theta. So this equation will come out minus 2a sine 2 pi x upon lambda cos 2 pi t upon t. Y is equal to minus 2a sine 2 pi x upon lambda. This is time function, this is distance function x. The value of y vary with distance and get maximum minimum. So this is called amplitude, or we can write this equation as y is equal to a cos 2 pi t upon t. Here minus sign can be omitted. Okay. So here where a is equal to minus 2a sine 2 pi x upon lambda and a is called amplitude of stationary wave. Stationary wave formed in bound medium by superposition of two progressive wave. अभी वैसे जनरल तो इक्वेशन यही रहेगा, is just to illustrate कि amplitude vary with distance as periodically. I hope you remember what the meaning of periodic variation. After a certain distance x, the amplitude will be repeating its value. Now, this equation shows as equation, I write it as 3, 4 and this is 5. So equation 5 indicates here that x vary with distance. Now you know sine 0, 0, sine 180, 0, sine 90, 1, sine 270, minus 1. So due to that a will be varying. Now position of nodes ढूंढेंगे हम. Position of nodes. of this equation. Note कहाँ बनेंगे? This is the equation of standing wave, and this represents variation of y with distance x and time t. Nodes, position of nodes. We know at nodes a is equal to 0. Amplitude of vibration 0. So from equation 5, 2a sine 2 pi x upon lambda is equal to 0, or sine 2 pi x upon lambda is equal to 0. My dear students, please make your mathematics strong. Keep on learning the mathematics. Nowadays, actually, I don't know what is happening. Students are not working hard. Dear students, this education is obtained by self-effort. It will not take place that your mother or father will work hard and you will get. Yes, they have to work hard to pay your fees, to provide you facilities which you need. You need perfect facilities nowadays because syllabi are very wide and some hidden syllabi are there. I have told you that in our this chapter. Definition of intensity wave is not there. And here we are talking about intensity and so many things again and again. So here come to mathematics. If sine theta 0, so what value of theta do you expect? Then theta will be 0, pi, 2 pi, 3 pi. And so on. So here how to write that? Or we write theta equal to n pi, where n 0, 1, 2, 3. So I can write here. So 2 pi x upon lambda equal to n pi. Pi means pi radian means 180 degree. Where n equal to 0, 1, 2, 3, 4 and so on. So here we get x equal to n lambda by 2. Position of node will be obtained by this equation. Putting n equal to 0, 1, 2, 3. So putting n equal to 0, 1, 2, 3, 4 and so on, we get the position of nodes at x equal to 0, x equal to lambda by 2, x equal to 2 lambda by 2, 3 lambda by 2, 4 lambda by 2 and so on. When boundaries are reached, we find that node is at boundary. Node हमारा कहाँ है? Exactly on the boundary. Okay. And you note here the distance between two nearby nodes, lambda by 2 minus lambda by 2, 2 lambda by 2 minus lambda by 2, this minus 3 lambda by 2. So distance between two nearest nodes is lambda by 2. Now we come to know position of antinodes. Position of antinodes. You know, at antinodes, amplitude is maximum. Therefore, minus 2a sine 2 pi x upon lambda equal to plus minus 2a. Plus minus 2a. Or sine 2 pi x upon lambda plus minus 1. Or 2 pi x upon lambda equal to 2n minus 1 pi by 2. Where n equal to 1, 2, 3, 4, not 0. From here x come out to be 2n minus 1 lambda by 4. X come out to be this. Putting n equal to 1, 2, 3, 4. Putting n equal to 1, 2, 3, 4. Putting n equal to 1, 2, 3, 4 and so on. We get nodes, we get antinodes. Antinodes at x equal to lambda by 4, 3 lambda by 4, n equal to 1, 2, 1 the 2 minus 1, so 1 lambda by 4, and 2, 2 to 4 minus 1, 3, comma 5 lambda by 4, and 7 lambda by 4, and so on. It means in case of this boundary, at boundary there is node and then next is antinode and then like lambda by 2 node. So node, antinode will be obtained successively in case of stationary wave formed in a bound medium having rigid boundaries. I will discuss in next video when boundaries are free, and then I will give you the vibration of string between two ends, the vibration of rod, vibration of a wire, etc. Very interesting topic is going on. I feel I should continue the thing, but there is limitation. You also get tired of watching video. Please share the video, like video, and ask your friend to subscribe my channel, please. Thank you.